Welcome back. This is part 5. It's on the factor theorem. Now, we already covered the remainder theorem, and we found that PA is equal to R, the remainder, when you're dividing by the divisor x minus A. Okay, so if you know and understand the remainder theorem, you can do the factor theorem because it's essentially the same thing. So this is our remainder factor theorem here. If a polynomial, when you substitute A equals 0, then x minus A is a factor of the polynomial. So when we do the division, the remainder will be 0. That means that x minus A is a factor. And we also modify our factor theorem as we did with the remainder theorem. If P, B on A equals to 0, then AX minus B will be a factor of PX. Okay, so let's try some example. That will make it clearer. So show that x minus 3 is a factor of x cubed minus 2x squared plus x minus 12. So look at our general form, x minus A. So in this case, A will be equal to 3. So if x minus 3 is a factor, PA should be equal to 0. So we'll put P3 into our polynomial and see if we get 0 or not. So we'll get 3 cubed minus 2 times 3 squared plus 3 minus 12. So that will be 27 minus 3 3s are 9, 2 9s are 18, plus 3 minus 12. 27 plus 3, that's 30. Minus 18 minus 12 is 30, minus 30. So that equals 0. So P3 will be equal to 0. So that means that x minus 3 is a factor of the polynomial. Okay, because the remainder is 0. Another exercise. So that 2x minus 1 is a factor of this polynomial. Okay, so the second rule, if P, B on A is 0, then AX minus B is a factor of PX. So looking at this here, AX minus B, so we must substitute in a half into here. So we put a half into our polynomial, 4 half cubed plus 2 half, right, 2 half squared plus 8 times a half minus 5. Okay, so you're going to get 4 times a half cubed is 1 on 8 plus 2 times a half squared is 1 on 4 plus 8 times a half, 2 into 8 is 4 minus 5. So 4 times 1 on 8 will be a half. 2 times a quarter will be 2 on 4, which is a half, plus 4 minus 5. Half plus a half is 1. 1 plus 4 minus 5. So 5 minus 5, which is 0. So we can conclude that AX minus B, we've got, roll back up to see, there it is, 2x minus 1. So P half equals 0. Therefore, 2x minus 1 is a factor of px. So just remember how you did remainder theorem. This here is the remainder. And because the remainder is 0, this must be a factor. If this number is not 0, this 2x minus 1 is not a factor. Example 6. Okay, so this has a factor which is 2x minus 1. Okay, which means that p to the half equals 0. And we want to find the value of k from this question. This is k here. So we know that p half should equal 0. So we'll substitute the half into x here. You have 2 times a half cubed minus 9 times a half squared plus 8 times a half minus 13, and that should be equal to 0. So we write this on the end here, equals 0. So now we have an equation and we need to find this k here. So half cubed is 1 on 8, so 2 times 1 on 8 minus 9 times half squared is a quarter plus k on 2 minus 13 equals 0. So we can do this without a calculator, not too many problems. 2 on 8 is 1 on 4 minus 9 on 4 plus k on 2 minus 13 equals 0. So 1 on 4 minus 9 on 4 is minus 8 on 4 plus k on 2 minus 13 equals 0. Minus 8 on 4 is minus 2. We have a minus 13, so let's put that there. Plus k on 2 equals 0. So we'll have minus 15 plus k on 2 equals 0. So k on 2 must equal, now bring your minus 15 to the other side. You'll get 15. Multiply both sides by 2. The k will be equal to 30. So k will be 30, and that will give us this factor as 2x minus 1. Okay, so when you come to your exercises, use the factor theorem to show that each of these linear expressions are factors of the polynomial. So in this case, you need to show me that p minus 2 equals 0. Go. X minus 3. So in this case, you need to show that p3 equals 0. In this case, p minus 5 equals 0. For question 1. Okay, question 2. You need to use the factor theorem to find one factor. Okay, so if you look at this number here, minus 1. I haven't taught you this before, so we probably need to talk about it. Minus 1 has what factors? 1 times minus 1. These are the two numbers you need to try. So try 1. Do you get 0 or not when you substitute? And try the other one. You only need to find one factor though, so just do it until you find a factor. And also try minus 1. Do you get 0 or not? In this one, look at the constant term, minus 12. Think about what are the factors of minus 12. Minus 1 times 12, 1 times minus 12, and so forth. 2 times minus 6, minus 2 times 6 minus 3 times 4, 3 times minus 4. So the numbers you could possibly try are these ones here. I recommend you start with the smallest numbers when you do this. Try 1. Is it 0 or not? That's what we're looking for. If this is 0, then we can say that x minus 1 is a factor. Okay, and then you try minus 1 if it's not. Yes or no. Then you go down to minus 2 and so on. Okay, just do it until you find one factor. We can try 6 and minus 6, 3 minus 3, and 4 minus 4. Okay, that's the way to find one factor. Okay, question 3. Let's show that this is a factor of this polynomial here. So in this case, P1 should be equal to 0, yes or no? It should be, because it says to show that the second polynomial is a factor of the first. In this case, you need to show me that P minus 3 is equal to 0. So that means you need to do the working, and you should get 0 when you do that. And do it the same for those two. Again, show that this is a factor of this polynomial here. Be aware you've got ax minus b form here. Okay, so this is like one of the examples. This is a factor of this polynomial, which is telling me that P1 equals 0. And do that like the previous example. Then you can find the value of a. This question is like the one we did with remainder theorem. So you've got P1. Now this should be equal to 0. You'll get an equation here, equation 1. Do the same for this one here. If the factor is x plus 1, x minus 1 should be equal to 0. And you'll get the second equation here. And these are your simultaneous equations. So solve them, and then you can find P and Q. Okay, that's it. So have a go at those, and I'll see you soon.